Thank you. Thank you, everyone. Nice to meet you. Good afternoon, everybody. Today is a little bit cloudy, but I wish everybody have a good mood. So, my name is Ai Lei. I'm working for Rakuten data scientist, data platform department. So today my topic is about technical deep dive into Rakuten data platform. To introduce about how our data platform looks like and our mission and some of the technical details. I wish you can join that. So firstly, I'd like to do a quick introduction about myself. So my name is Ali again, and I come from China. I joined Rakuten since 2018 and working as a data architect for the Rakuten data platform department. Myself, I'm hands-on engineer, so I like design and implementing about all these big distributed system and data applications. So before Rakuten, I also worked for some other companies. So till now, I'm working with this industry for more than 19 years. So once after I graduated, I was not confirmed which area or which kind of industry I was going to do. So I also changed a lot of industry. I started from fintech, and later I changed to telecom, and then I moved to big data and other e-commerce industry. So I found eventually what attracted me is about I need to do some more hands-on work, and also I don't really like real challenges, and I like to resolve all the real problems with creative ways. So that's why I'm working here for Rakuten. Thank you. So to start with, maybe that platform is a very big concept. Maybe many of you may be curious about how that platform usually works in Rakuten. So I'd like to start with some use case study first to have a high-level impression to you how this use case usually work in Rakuten. So first case is about data analytics use case. So image yourself are a business owner for Rakuten BU. For example, you own a business like, for example, Rakuten Ichiba or Rakuten Point. So how do you want to measure your business is performing good, or it is performing bad, or which kind of perspective you want to improve? So traditionally, like you have to talk with different owner. For example, your internally, externally. For example, you talk with your sales team to understand how the sales is going, and you talk with your operation team to know how this cost is all going, right? And also you talk with your user customers, maybe understand about their problem, their business partner, or their how their business is all going, right? So all these things probably need to be manually collected, do some analysis, and then it will be somehow also delayed, right? So when the result come to your side, so that is a maybe trouble for the data analysts, and also that's another use case for data platform try to address. So with a data platform help, so a business owner every day come to office, they will automatically review all these reports regarding the KPI, regarding all these performance of the BU, whatever you want to measure automatically. So you do not need to ask people again and again to give you data, right? So analysis, you will have that with all these charts by yourself. And then if you find anything which probably not working well, then you will have the requirement, or you made some decision which part you want to do investment or improve in application. For example, you want to do some new feature, or you want to do some new campaign in Rakuten Ichiba, you will do enhancement here. And then again, later this part will reflect data will be collected in either any kind of databases or events or API things. And then next step is we have data engineer. So collect all this data, store it in some kind of format. So sometimes we call it data link, or sometimes we put into data warehouse. You may heard of all these terms. So data engineer team, those people mainly focus on this moving data, transforming data, massage data to make them kind of accessible format in somewhere. And then we have maybe you also heard about data analysts. Their mission is to get all this data to create all these reports to add insights to business owner decision at BU, for example, different BU boss. So they will help them to do better decision making. So this is from end to end. This is like one typical use case as a data platform. So next use case. Also like to share about another use case is like you know that in current days, when we do when we offer a business or offer a services, it is critical to provide services based on user interests. So we call that customized services. So because different user may have different needs or habits or requirements, right? So it is better to provide service based on their real requirements, based on their characters, right? So if we, for example, use a traditional shopping mall or those kind of services, it mostly likely you visit the store, you explore it by yourself, and you get a common service, right? The same service for all the users. But with the modern business model, is look like each different user, for example, you use Rakuten Ichiba or you use something else. Each people, when they log into a system, they will get something different based on their habits, their interests. So that's a typical modern application or business model works, right? Okay. Also, imagine like when you explore YouTube, or when we see when we use, for example, TikTok, you will see all these different contents based on your interests. So this is like a critical part is how we do user profile properly. So this is also another critical part of the data platform. So with the data platform, we are able to collect users' behavior, to understand user more well, and with all this machine learning data scientist team help, we'll have more accurate understanding about users' interests and behavior and their what they want. Then the business team will make different campaign or advertisement, even online, offline. All these business can be worked together to have better result. Of course, all these different campaign advertisement eventually will be feedback into the data collection part to further understand whether this kind of, for example, business activity is appropriate or not, have a good result or not to all these different users. So that's another typical use case for data platform. But yeah, of course, as a data platform, it is very big, especially in big company like Rakuten, to have many other use cases. But I like just firstly share these two use cases at the start to help you have an understanding about overall how it works in general. So upcoming next, I'd like to have an introduction about how this entire data platform, the scale it looks like. So we cover about more than 70 services in ecosystem. And also entire data set is more than 30,000. Our in direct user, I mean, here is 1,000 users, but of course, to all these external users, maybe more indirect user, it will be impacted. So given all this scale is a big one, and also like to introduce a little bit about the different user. What will be the users who are using with this platform? So of course, the first type user is data engineers. As we know, they will set up the job. They will do the data moving job or manipulation, transformation job. They always come to us asking for set up the job with a better performance because we are dealing so many huge amount of data every day. So SLA is also a critical metrics for them. Of course, we mentioned about data scientists and machine learning, those team, deep learning teams. Their requirement to us is whatever you provide the data to us should be easy to use, should be clean. Of course, also better performance. So, but although not only these analysts or data engineer, but also the security, data governance, they will have requirement about we should build a platform with a better security standard so that make sure users' data is not being leaked out. That's also always making very serious security problems. And for example, of course, for system administration and other operations, their requirement is more like transparency on the system. So make sure all you build your application from end to end is measurable, understandable, easy to observe, monitor, all these things. So yeah, that's a typical setup for users. And then next, I'd like to have an introduction about what will be the general challenge to build such a data platform. So of course, firstly, as I introduced earlier, this platform has large scale of user. So different users have different profile. Their expectation is different. We need to build a platform to meet all these requirements. It's not an easy job. And of course, because build a data platform, we cannot build by ourselves. We always need to study from external to understand what will be the industry best practice, whether that can be applied into our Rakuten internally. And of course, we have to manage all this large scale data jobs every day or real time, and make sure the data is always available with better quality on this is definitely. And eventually also nowadays, the machine learning data scientists are becoming very, more and more critical. So I have to make sure that data is available, is ready, easy to integrate with all these different AI and machine learning industry technologies. And of course, all these things will be built on top of solid, scalable, easy to upgrade all these infrastructure framework. So I can see all this is a very challenge to build that platform. So what is our approach to achieve, to accomplish, even we face so many challenges? So in high level, we have this kind of roadmap. So we started from the data warehouse era. So in that kind of time, everything is structured. So data warehouse, later I can also do a little bit deeper dive on that part. But in high level, everything is structured, very fully managed. It is good in terms of performance, but we have some scalability issue after it coming to some period of time. So then next, we introduced data lake house, data lake concept in Rakuten. So we have the Hadoop integration. So data lake is coming to the team. It is easy to scale. It is open to integrate. So a lot of users can easily integrate their application, their data into the system. But later we found some more problem. It is easy to manage because it is so flexible. So it can be a little bit out of control, right? So also that quality and all this is not easy to manage. So, and then we also face a scalability issue. So that's we start the third phase. We call that hybrid data platform. The main motivation was to resolve the scalability across all these different regions, different data center, on-premise and public cloud challenge, right? So sometimes our on-premise data center is not scaled that fast compared with public cloud, right? Because all this business was growing so fast. They collect so many data daily by daily, and it is growing rapidly. So all the infrastructure is a big challenge. So we start our hybrid cloud platform era to accommodate, so that we can accommodate all these challenges quickly. And now we are working for the data lakehouse type. So the purpose of this part is to make sure we can have all this openness for the data lake that you can easily integrate all these different applications, integrate with all these machine learning AI things, but also it is manageable. So the data quality is under control. The performance is also can meet the user requirement, and data governance is also can be meet the requirement in a central place. Yeah, so that's currently work we are working on. So I'm coming next. I'd like to take a few of typical technical issues to do a little bit deep dive. So firstly, I'd like to introduce a concept. It is known as software-defined data platform concept. So as we introduced earlier, so we are facing the scale problem, right? So we have so many ETL jobs, data loading, data manipulation, all these jobs, which you have to address every day. So it is very painful. We maintain this manually. So we need a service defined, right? So that's firstly, we define so-called the platform API, so that all this data operation, loading, all this job setup, all this loading, we do a proper abstraction, and they can be defined as servers, API servers. So user can interact with these API servers by its portal or either command line SDK easily to integrate. So after the data job was set up, and the next data loading was set up, the next challenge will be the data job. We have so many jobs, tasks running every day. So if you take a look at the entire system, it will be like more than 1 million, maybe or less, the 1 million jobs, tasks running every day. So how this task will be managed properly, we need like, for example, framework like Airflow or any other open source tools to integrate them together to make sure all this alert, retry, and all this monitoring can be properly set up. So all this is not also need the proper abstraction and structured way to set up all this job, right? So that's another way we have to do proper definition of all these job setup. So it can be integrated end-to-end by the APIs. And then coming next is about the, if you have all these large scale data jobs tasking running every day, the computation resource and your application job is basically you work with huge amount of data. You work with petabyte of data processing. You have all this Spark, Apache Spark, and other like Trino, Hive working every day. How you manage these resources with a more efficient way, that's another challenge. So I have to define the application with more structured way, and also do a proper like dynamic scaling up, scaling down for all these resources. So that's another perspective. We define all these flexible automonitor framework to make sure all this data application can be running in a management way, right? So lastly, regarding the data metadata. So if you manage so many data, the metadata itself also become big data. So you have all this, you make sure all this metadata is clean, but good quality, and also searchable, right? So with all these things, we have set up the based on Apache Atlas and Ranger, also with Solar as a total solution to do that. So this is the first concept, so-called software-defined data platform. So the next one I'd like to introduce is about the data availability across different data center challenge. So now because we have Rakuten, a big company, so we have different data center across Japan, and all across all these data center, each data center we have different setup. So for example, some data center we have Hadoop HDFS, which is a POSIX system interface. And then we also have object storage based file systems. So all this storage, and they have different interface, right? How we should work with all the different technology smoothly, seamlessly. The other challenges we have covered earlier, we also have to work together with the public cloud. So also public cloud has some special technology setup right there, right? So we have GCP, then Google Cloud. How these things should working all together? There will be mainly two problems. One is how you should make sure the data can be available in all these places so that you can have the data locality benefit, right? By doing such kind of things, we can make sure all this data can be replicated into different data center with very efficient way, so that all the data streaming users, they can have the data locality benefit. But even given that, still it cannot resolve all these issues. Still, sometimes you have to cross-join the data from different data center, different storage type, different technologies. So we also provide another so-called data mesh engine. So this based on the Chino. So Chino can provide a better interface to join all this data from different cluster, different location, different interfaces easily. So that's another part I like to share about the data availability challenge. So the last challenge I'd like to do a little bit more sharing is about the lakehouse challenge. So as we covered earlier, during our roadmap evolution, we have been tried data warehouse. We know it is good for better performance, structured way. And then we introduced data lake. It is open, but you know that data lake usually that people dump a lot of garbage. It is not easy to maintain, and not easy to do data quality assessment and data governance, right? So why we introduced data lake is to join the benefit of these two technology, and also we can provide a single source of truth. So that makes, we want to have a single place so that all this data, at least the data storage, can be in a single place. So for data engineers, it is easy for them to manage the ETL jobs, right? So we do not want to set up all these redundant jobs to copy data from one single place to the other place, but all the contents are same, right? So that's one benefit. The second benefit is for data analysts. For them, even they're happy to learn all these new technologies, but they also wish to have a unified interface to query all this data, right? So they do not need to always change their application time by time due to the underlying technology change. And also for data governance team, they want to have a unified interface, just single place to check all the data access, make sure all the data access sharing can be under control to reduce the security risks. So by that, we are introducing a big lake solution so that you can still have the openness. For example, you integrate the Apache Spark, integrate with Trino, integrate with all these machine learning framework applications, but also can have benefit for warehouse, like enjoy the BigQuery and other warehouse feature to make sure that data can be queried in a high performance. Of course, it also provide a unified interface for data governance to check. So that's all these three typical technology problems we have been encountered, and I'd like to share here. So upcoming next, what is our goal? So we know that now AI is a very hot topic, right? So as a data platform, it is also a key component to enable the AI adoption. So because all the data is coming to the data platform first, and then integrate all these AI applications. So of course, our engagement will be two parts. Of course, firstly, we want to make sure all the data flow from data to AI module, machine learning, training, deep learning, all these things can be more efficient, especially for large language models, how we should efficiently manage all these structured data and provide the better utilities for the LLM team to build their good models. That's one challenge we need to do. In the other way, so if we are able to build a very mature large language model, and then we also like to use this model to help our data analysts to be more efficient. So as we know, nowadays, people still need to do a lot of pre-study learning to do a proper data analysis, right? So, but we wish have this, for example, LLM model, large language model help people come to the system just ask simple questions. For example, I want to query this KPI for this business, right? So I just ask them, hey, this module, which kind of query data I should use, which kind of query I should use, and which kind of dashboard I should set up. And then it will be quickly help you to set up all these things. So yeah, that's another way we should want to leverage all this machine learning technology to make sure the data analysis is more and more efficient in the future. Yeah, I think that's basically everything. But lastly, I like to also introduce our the team culture and the working experience in Rakuten. So based on our teams as an example, but I think it will be typical team apply to other team as well. So as you know, this is like a data platform is a very mission critical team. We're working on it. We have so many challenges every day. So everything requirement is changing and getting very quickly. So we have a lot of pressure for sure. But with all these challenges, actually it's very good for the engineer team. So it pushes us has to be work as a team work together, right? So we have to stick together, have very collaborate way to work together, to share knowledge together with each other. So that's one perspective. I feel with all these mission critical tasks and all these business impacts, big business impact BU we are working on, make the team working more closely. The second one I would share is the team is a very diverse way we are organizing. So we have team member coming from more than 10 different countries in a single team. So we are respecting each other. We learn the different cultural difference from each other. we share all the different countries' interests and share. When we're doing all these offline activities, like Naomi can choose different countries, flavors, restaurants. So it's very diverse environment. But yeah, eventually our goal is to build a trust-based team. Trust is the foundation of our team. Based on that, we will be able to explore new technology, apply that, and also offer all these business values to our customers. Yes. Thank you for this chance, today's chance to meet you. That's all from my side.